Hey everyone, let me introduce my implementation of a RAG question answering system task. First of all, I would like to show that I have locally running LLM ollama that run LLM model. It is work. Here's the sentence that here's the answer that it sent me. Next, the server is running. We have some information about what? About using provider LLM, about vector database Pinecone initialized successfully, about Hugging Face embedding initializing. That means that data embedded by Hugging Face interfaces. I have 150,000 documents in Pinecone. A search configuration, top 5 result. It means that search will give top 5 result as a context, and we choose only if threshold above 0.5. And the server is running. There is a docs for server. There is main statistics. It works. We can check what we have in Pinecone database. Yes, dimensions it used, threshold, and museum name. Here by our database Pinecone, and we have the same data because this endpoint sent us the same information. So the server is running, the LLM is running locally, and the client interface is also running. We can test our application, but first I would like to show that all data were downloaded from GitHub here and placed to temp collection. So all data is proceed by script and divided by chunks as required by task and placed to document folder. So we can see here chunks that after splitting proceeded with the embedding servers that Hugging Face provide technique and placed to the vector database. So all these data from GitHub divided in chunks, vectorized and placed to the database. So my application works with this data. Let's go to the interface, web interface. It is written in React, and let's test our RAG system. Let's take provided examples. For example, this first one. We put it, paste it here, and ask our model. It takes some time to get the response because it's running locally, pending. After putting the information in the input, the same technique for embedding query is used as for chunk preparation. And after embedding the request, it search based on these vectors. The searching process is starting from Pinecone, and the response return us such data where we have answer and source document. So these 5 chunks based on our settings we got from Pinecone database, and based on this context our model generate the answer that we see here on the screen. So show me American painting from the 19th century, and we have there are 3 paintings from the 19th century in the museum collection. Portrait of a man, first, second and third. It works correctly. Let's check another question, another information. So again we need to wait for some times, perhaps for minutes or 2. Let's inspect how much time it took for previous answer. It took 30 seconds, not much. Yeah, this one took 24 seconds as well. So find artworks with floral motifs. Based on the documentation, there are 2 artworks with floral motifs or nature themes. So the information looks relevant to our question. Let's check something else. For example, this one, find portraits by the female artist. Let's go here, ask our model, and wait for the responses. Here, a small loader. The interface is very simple, just to check it is working. So it took 16 seconds, it less even. So find portraits based on documents. There are 2 portraits created by female artists in the museum collection. So the information looks relevant as well. Also, I would like to show that a kind of cache is implemented. I used local cache memory. So if I send once again this request, let's take a look what will be. We have the answer immediately. That means that we used it from cache. We can take a look on it in the logs, because I added logs to my application. So ask result based on document provided. So ask result, ask cached. So every request is logged here. Ask result first. There is no such answer in the query, in the cache. That means we wait for the answer. So let's again ask and take a look here. Again, we used this answer from cached. Cached is expired in 10 minutes, so after 10 minutes of using application, a new request will be sent. That's why it provides us a quick optimized action in our application. And let's take a look at the last one. So there is no cache. Yeah, ask question. That's why searching for this question is started. Found 5 relevant documents, and after finding relevant documents, the model generates the answer based on these documents. Let's wait for a second. It's the biggest answer. I can see it. Japanese ceramic. Is it relevant information? So as an expert museum curator assistant, I can tell you that Japanese ceramics are a significant part of the collection and the institute. So